class session, we are going to be discussing about flip-flop, Unit 2. And the earlier Unit 1, we discussed about gate, right? So what's the main difference between flip-flop and the gate is? Gate takes a 2 or more input and produces single output. But in the flip-flop, now it takes a 2 or more inputs and produces 2 outputs. The main difference is gate is produce a 1 output and flip-flop is produce 2 outputs. The 2 outputs are complementary to each other, which means one will be the 0 means another will be the 1 and another one means another will be the 0. So the definition for the flip-flop is it's a bistable multivariate circuit that has taken 2 or more inputs and produces 2 outputs. Right? Flip-flop is nothing but it is a on the bistable multivariate, that is bistable means that's a 2 bistable multivariate circuit that has taken 2 or more inputs and produces 2 outputs. The 2 outputs are complemented to each other, right? That means a 0 means one output is a 0 means another will be 1. If it's a 1 is the 1, another will be the 0. It is used to store a bit of information, that is a 0 or 1, like that will be used for that, right? So the flip-flops are used in many digital electronics nowadays. You know that television in home nowadays, okay, all the televisions comes with the digital circuits. If any circuit will be, if your TV will be files now, simply the circuit will be replaced. Everything will be there. Digital timer, digital watch, and digital watch strap. Everything are nowadays using the flip-flop concepts. And the word flip-flop or latch also have something like a simple difference. So what's the difference between the flip-flop and versus latch? Flip-flop is nothing but it is a edge-triggered flip-flop, but and what happened then? Latch is not there. Okay. So what will be the difference that we are going to be discussed? Flip-flops are edge-triggered. That means and it consists of a positive edge trigger and negative edge trigger. Right side of the diagram, you know that. Right side of the diagram, you know that the first diagram is a positive edge diagram. The arrow is there directly now. And the second arrow, you know that the bubbled is there, that is a negative edge triggered. Right? Flip-flops are edge triggered and outputs are based on passing the clock input. Right? So we can also passing the clock also will be passed as the input. This is used the asynchronous counters. Edge triggers are positive edge trigger and negative edge triggers. But the latches are nothing but that will be based on the what is the input that we are going to be passed, that we are going to be get the output. That will be the differ. But flip-flops are we are going to be passed their input as well as the clock input. Based on the clock input also, the output should be varied. But latches are not. Latches are passing the input. That means maybe something like we can pass an SR, we can have a JK or something like anything like that. Right? So input only there is a latches, no such concept of clock input, but the flip-flop we have the concept of edge triggers. So there are the 4 types of flip-flops there. One is RS flip-flop, the second one is a JK master flip-flop, the third one is a D flip-flop, and fourth one is a T flip-flop is there. Okay, RS flip-flop, the gate designed with the NAND gates. You see that there are the 3 inputs, S and R, S means set and R means reset. This is the major input we are going to be passed there. And the clock input, they may be a 0 or 1. And first gate 1 and 2, and third gate, third NAND gate and fourth NAND gate, and the 2 outputs Q and Q bar. You see that the third NAND gate output is connected to that fourth gate input, and fourth gate output are passed to the input of the third NAND gate. Clearly know that third gate output is passed to the input of the fourth NAND gate, and fourth NAND gate, right, output is passed the input of the third and input. That is, the output are right afforded to connect to each other, third and fourth, right. So the flip flops consist of two inputs R and S and two outputs Q and Q bar. The two outputs are complemented to each other, right? And the clock also we are going to be passed there. That will be a 0 or 1. The two outputs are like the set and the resets there. Two inputs set and resets there, right? Right. S and means set and R means the reset thing. There are the four important conditions, right? And we are going to pass the two input 2 power 2. That means we have the four possibilities. When S is equal to 0, R equal to 0 and the clock equal to 0, you are not doing any operations. You have a laptop in your home, you have a TV in your home, you are not doing any operations in that. What happened then? The laptop or the TV as it is in the present state. Okay, present state as it is then. The same thing. The circuit, digital circuit is as it is. Okay, you are doing not any operations. You are not doing any operations. S is equal to 0, R equal to 0 and the clock equal to 0. You are not passing anything. The same thing will be as it is. You see the point is, right, Qn remains unchanged, right? And even for S is equal to 0, R equal to 0 and the clock equal to 1, the flip flop remains the same thing, the state, right? Okay. The Qn n plus 1 and the Qn are in the same thing, okay, same state, right? That is the previous state and next state, that is there. Case 2, when S is equal to 0, R equal to 0, reset equal to 1, okay, and I am going to pass the clock input equal to 1, 0 pass, I am going to pass them. The flip flop remains in the present state, right? When I am going to pass the clock equal to 1, when I am going to pass the clock input 1, the output of Q becomes 0. The output of Q becomes 0 and I am going to pass the input, right? I am going to pass the input, okay, that is, you see that R equal to 1, alright? S is equal to 0 and the clock equal to 1, I am going to pass, the output of Q becomes 0. Okay, in this case the flip flop resets, okay? Suppose if you have a laptop in your home or TV in your home, right? You have pressed the reset button. What happened then? The computer is restarted. Okay, the computer is restarted. The same thing, the flip flop reset the state, right? Reset to the 0 state. Suppose if you have a TV in the home, you have a button there, restart something. What happened then? You press the button, what happened then? The same thing. You restart the TV. The same thing like case 3. When S is equal to 1, R equal to 0. Set the condition. And the clock equal to 0. You are not passing this clock equal to 0. In this case, the flip flop remains as in the present state. When we are going to be clock 1, okay, the flip flop, the output of Q becomes 1 and the flip flop will be sets the 1. When we are going to be, okay, switch on the laptop, right, or switch on to the computer, what happened that? In this case, the TV will be on there, right? The same thing will be used for that. Means to set the state. The flip flops are set to the state, okay, set to the, okay, the state. Case 4, when all the inputs are equal to 1, S is equal to 1 or R equal to 1, something like, and the clock equal to 1, it will never happen there. Suppose in the remote now, you have an on switch and on off switch. Directly press it. Both the thing is, if you have a kid in home, okay, the kid is playing a game, okay, with the help of something like a digital game like that. See, press both on off button. What happened there? Okay, randomly value will be there. One will be there 0 and one will be there 1 like that. Okay, so that will never happen there. Okay, in this case, what happened there? This is an intermediate, okay, indeterminate state. Okay, that means happened that the state will be called as a forbidden state. Thank you.